In this video, I want to talk about a simplified way to use XBAS with the dual discrepancy consistency model of PSW. And I made this video because I think the model has an unfair reputation for being complicated, when in fact it's very simple. When people say it's complicated, I think they're usually talking about the software. But I'm going to show you how that's not hard either. And if you're spending 15 minutes entering scores in XBAS, I'm going to try to talk you out of that. And I'm also going to offer some ideas that will not only make things easier, but I think they'll make your assessments more valid. And as we come to the end, I want to address a major criticism of PSW and what I've learned about how we can make it better. But I want to say for the record that I am PSW agnostic. Like most people in the field, all I want to do is help kids. I only learned about PSW because my district adopted it. So I'm not here to defend it. I'm here to make the most of it. What I will say, though, is that none of the PSW critics seem to be putting forth a better option. All right, so let's get started. Now this is the main page. And XBAS is a great piece of software, but it has more tabs on it than I care to count. And I think it was made this way because the authors are trying to teach the model through the software. But the problem is that it continues to teach the model every time you use it. Once you know the model, almost all of these tabs are unnecessary. In a typical assessment, I use 3 of these tabs and arrive at the exact same place with the exact same outcome. And the authors provide the Quick Analysis tab to allow for this, but I don't think they give it enough emphasis. So I'm going to show you how I do it, but first, we need to go analog. If you go to this website, pswmadeeasy.com, you can look on the Tools tab and find this document, and you can print it, preferably as one double-sided page. It's a Word document, so you can revise it any way you want. This is what works for me, including my usual tests. My preference has been to use the Whisk as my core battery and the Woodcock as my secondary battery. So I always have a good idea of what my follow-up tests are going to be if I need them. If I change my mind, I'll cross out the pre-written subtest on the page and write in what I used. But I don't feel a need to stray all that often. The goal is to get the best measures of the most important narrow abilities, and these usually work for me. Now I'm not going to make you watch me do a full evaluation, so I'll do the front page only and go from top to bottom. In a real assessment, I write the scores down as I go in the order of test administration. So I'm jumping around among the various sections and flipping the page over and back. You get used to it. All right, so on the Whisk, I'm starting with GC, and the kid gets an 8 and a 12, and a composite score of 100. Do I need to follow up? I don't think so. The software would talk about cohesion, but for me, cohesion is not the driving issue about whether to follow up. It's a simple question of whether I'm confident that the ability is a strength or a weakness. In this case, the composite is average, and both subtests are average or higher, so I don't feel a need to follow up on this. So I circle the composite I used, the VCI, so I know where the score came from when I transfer it to my reports. In the right column, I indicate the ability as a strength, and then over here on the left, I like to put a check mark to remind me that GC is done. Moving on to GF, we have a 6 and a 9, and the composite is 85. And this time I do want to follow up, for 2 reasons. First, when I look at the subtests, the lack of cohesion doesn't bother me, but I'm concerned that the 6 looks like a weakness and the 9 looks like a strength. But more importantly, that 85 is right on the threshold of being a strength or a weakness. And I've decided that pretty much any time I get a composite in the 80s, especially near 85, I'm going to follow up as long as the kid is still engaged. There's a risk of over-testing, but in schools, time is our currency, and I would rather spend a few more minutes while I have the kid than add another session later. But again, that's what works for me. So in this case, I really don't know if GF is a strength or a weakness, so I want to follow up. And instead of writing in the 85 composite, which I know I won't use, I circle XPass, which is where my composite is going to come from after my follow-up testing. Then comes GWM, and we have a 13 for digit span, but now we're kind of stuck. I give digit span because I need it for the full-scale score. But after that, there's nowhere to go. Picture span measures visual working memory, which means almost nothing to academic learning, so it weakens the composite. The other option is letter-number sequencing, which is too much like digit span. The subtests that make up your composite should involve separate tasks, so we can do a better job of assessing the underlying abilities and not just a specific task. Letter-number sequencing and digit span feel too much like the same task for my comfort. So I don't feel like I can get a good working memory composite from the WISC, which means I always need the XBAS composite. Now, since we're only doing the front page, that means I'm done with the WISC and it's time to move on to my next test. So let's see what we need. GC is done, but I need to follow up on GF and GWM, and I need a full measure of GL. And I can get all of that from the woodcock. Now notice that I try to do the first round of testing and the follow-up testing at the same time. So instead of measuring all the broad abilities first, and then coming back to follow up, I do it test by test. I exhaust the first test, and then I see what I need from the second test, both for following up and for any new areas. And then I exhaust that test, and again the next one is needed until I'm done. So that's why I score as I go, so I can see in real time what I need to follow up on. All right, so starting with GF, I need to follow up. And the authors of the model advise us to follow up only on the lowest score because it saves time. But be careful, because the cost of that convenience is that you could wind up with a less valid composite. And it's complicated, not because the DDC model or PSW are complicated, but because measurement is complicated. Because the difference between the 6 and the 9 might mean something or it might not. Matrix reasoning and figure weights represent different narrow abilities. But that doesn't mean they actually measure those abilities, because they don't. Again, they measure the abilities to do specific tasks, and we use that information to make inferences about the narrow abilities. So the 6 and the 9 probably just reflect your abilities to do those tasks, which really don't mean anything. Like, when in life have you ever accomplished anything by solving a matrix puzzle? Right? But the problem here is that if the differences are real, and they do reflect different narrow abilities, then following up only on the low score could bias the composite toward a lower score and make it less valid. So I think we should spend the extra 5 minutes and retest both narrow abilities so we can ensure a more valid composite. Okay, so on the woodcock, I get scores of 86 and 101. And I don't know what the composite is yet, but I know I'm done testing GF. So I check the left column and move on to working memory. And here on the woodcock, I get a score of 105. So again, I don't know the composite, but I know this is a strength. So in the left column, I'll check that I'm done. And finally, we have GL with a 109, another 109, and a composite of 111, which is also a clear strength. So I circle the test composite, mark it as a strength, and on the left, I check it to show I'm done. And if you've ever wondered how two 109s can make a 111, think about why Michael Phelps is considered the greatest competitive swimmer of all time. It's not because he won a gold medal at the Olympics. People win gold medals at every Olympics, although it's very unusual among the general population. But if winning one gold medal is unusual, then winning more than one is more unusual. Michael Phelps did it 23 times, which is more unusual than anyone in the history of the Olympics. winning 23 gold medals is not the same as winning 1 gold medal, right? A score of 109 is only slightly unusual, but if you do it twice on separate tasks, that's slightly more unusual than doing it once, which is why you get a more unusual composite. And there can be several factors that influence this. As the subtests get farther from the mean and increase in number and decrease in correlation, the composite will start to look very different from the subtest scores. But it's still a better explanation of the test performance, even if it doesn't look right. Okay? So now I'm done testing, and I look at the whole page, and I look for the abilities where I circled XBAS, because the next step is to go to the software and calculate the missing composites. So here's the opening page of XBAS. And if you haven't done it already, you should go to the user mode and change beginner to advanced. Otherwise, you'll get a lot of pop-ups that have nothing to do with what I'm showing you. Okay, so to begin, the usual step is to click the Start button and create a record with the demographic information. And you can do that, but I don't bother with saving records anymore, because if I need to see the results again, I can re-enter the scores faster than I can fill in the demographic information and then save and retrieve the record. So the only time I save the record now is if I'm using the CLIM. Otherwise, instead of clicking Start, I click the Index button and go straight to the main page. So I said I use 3 tabs, and the first one is the XBA Analyzer. And for me, this tab is what makes XBAS really special. The way it automatically makes valid composites from different tests is a real game changer. So we look for the areas where we need to calculate composites. And the first one is GF. Now, one thing you don't need to do is click on this line to get a pull-down menu and then select your subtest. It's time-consuming and you don't need to do it. All you need to do is copy your scores into these boxes, and the XBAS will calculate the composite for you. So entering the names of the subtests doesn't affect the outcome. What can affect the outcome is using the wrong section. So don't put your GF scores in the GC section, because they correlate differently, and you might get a different composite. Now in this case, the software gave me 2 composite scores. And if you want to use 2 composites, you can do that. But a single composite makes the interpretation easier, and in my opinion, it makes it better, and I want to explain why. Now the explanation below is that 2 cohesive composites are more meaningful than 1 non-cohesive composite. So let's talk about that. If we're going to use 2 composites for 1 broad ability, my first question is, are the composites valid? Now in 2018, Schneider and Roman analyzed millions of data simulations and found that cohesion doesn't affect validity. And in fact, removing divergent subtests from your composite will make it less valid. And the DDC authors don't dispute this. They even reference this paper in the XBAS software. So again, their concern isn't whether non-cohesive composites are valid, but whether they're meaningful. But if a single composite containing the divergent scores is valid, and if removing divergent scores from a composite makes it less valid, doesn't that mean you're substituting 2 invalid composites for 1 valid one? If your composites are less valid, how can they be more meaningful? My second question is, can an ability be both a strength and a weakness? As soon as you start dividing an ability into its parts, you're not talking about the same ability anymore, right? You know, it's like spreading peanut butter on a slice of bread and jelly on another slice of bread and calling them both peanut butter and jelly sandwiches. So I think what we're really doing here, without saying it, is choosing not to measure GF at all and to substitute measures of the narrow abilities instead. So then the question becomes, do narrow abilities explain achievement better than broad abilities? Now, sometimes the answer is yes. That's obviously true of GA, where everything but phonetic coding is irrelevant. GLR isn't even recognized as an ability anymore. We separate that into GL and GR, but rapid naming is separate from other tests of GR. And in GV, visualization is the only narrow ability that even matters. But those things should be part of your test planning. In this situation, when you're trying to get a broad measure of GF, and you find differences in the narrow abilities that you weren't expecting, and the narrow abilities don't predict different outcomes, I don't see how we can say a narrow ability interpretation is better. And let's look at what happens when we try. Let's say you have measures of reading comprehension and math problem solving, because GF is important for both of them, right? And let's say reading comprehension is a strength and math problem solving is a weakness. So you could say the strength in sequential reasoning supports the child's strength in reading comprehension because you need sequential reasoning to connect cause and effect relationships in a story. And the weakness in induction helps explain why the child is struggling in math because you need induction to generalize from past problems to solve new ones. So it kind of sounds like it makes sense. But what if the child had a weakness in sequential reasoning and a strength in induction instead? Would you then say the strength in induction helps with reading comprehension because you need induction to figure out the main idea of stories, and the child is struggling in math because you need sequential reasoning to decide which operations to use when you're solving word problems? And now imagine you discovered you had made a clerical error, and the child really has a strength in math problem solving and a weakness in reading comprehension. Would the cognitive explanations switch back? The authors of this model encourage us to balance the science with the art when we develop our composites. But in a case like this, where you can just make up an explanation for every possible outcome, that's not science, and it's not art. That's a fortune cookie. You read your fortune and it says, good luck is right around the corner. And the next week you find $1 and you say, oh my God, the fortune cookie was right. The fortune cookie wasn't right. You made the prediction fit the outcome by cherry-picking information. And that's exactly what we don't want to do in our assessments. When you have a conceptual framework that's so general that you can use it to explain everything, that's another way of saying it doesn't explain anything. So unless you plan ahead to target specific narrow abilities that predict different outcomes, I don't think two composites are meaningful, I don't think they're valid, and I don't think we should use them. What we should do instead is click the Evaluate Score Configuration button, and the first option is always to make a single composite. So we click Yes, and there's your GF composite. And if you read the fine print below, it says a single composite may be necessary for the purposes of SLD identification, particularly within a PSW framework. So this is a legitimate use of the model, according to the authors. Now it goes on to say that the narrow abilities might be more meaningful, but again, I really don't think so. So in my practice, I use single composites every time for every ability, unless I planned otherwise prior to testing. Everything else to me is a fortune cookie. But also, if separating an ability into two composites is problematic, then separating it into one composite and one divergent subtest is much worse. It has all the same problems, plus the added issue of relying on a single subtest, which amplifies the least reliable part of your data and gives it the same weight as the other three scores that make up a composite. So even if you think you have ecological support for it, I think the most likely explanation for that divergent score is still just measurement error. And to separate it this way just feels like an act of distortion of the interpretation of your scores. So again, the easiest and best thing to do is to just click the blue button and include the divergent score in your composite. Unless it's really divergent, which means it's probably not valid. And then you shouldn't use it at all. And if possible, you would measure the ability again with a similar task. All right? So coming back to our case, now we have a composite of 88. And the next step is usually to transfer the composite to the data organizer. But again, that's an extra step and it's time consuming. So instead, I'm going to transfer it to my sheet of paper. So I'll indicate that GF is 88, which I'm calling a strength. And we'll talk more about that in a few minutes. But let's also add the composite for GWM, which we didn't demonstrate, but that was 112, and also a strength. All right, and now we come back to XBAS, and the second tab we're going to use is PSW Quick Analysis Data Entry. And that's where we transfer all the composites from our sheet of paper into the software. But let's start by looking at the disclaimer on top. It says this tab should not be used by itself to establish the presence of SLD because it doesn't evaluate cohesion or assess follow-up, which reinforces the point I made at the beginning of the video that the software teaches you the model every time you use it. I don't need the software to help me through that process anymore. And then it goes on to say, the findings must be bolstered by additional corroborating evidence, including a full analysis via the PSW Analyzer. And we're going to do all that. So I know this is a legitimate way of entering scores because you end up on the final tab with the same results. All right, so to begin, if you didn't enter the demographic information on the start page, you need to enter the student's grade and if they're an English learner. And now we can enter the scores. Notice there are 2 boxes for each ability, just like when you do it the traditional way. So if you want to ignore my advice and use 2 composites for a broad ability, you can do that. And you should do that if you disagree with me. I'm telling you what I think. I'm not telling you how to think. Okay, so GC is 100, and moving down, I use the 2 GLR boxes to separate GL and GR. So then GV, GS, and in the second column, we have GF, GWM, and GA. I also need to enter a rapid naming score, and I could do it here, but I don't like the way it automatically says there's a moderate relationship with achievement, so I always put it in the GR box at the bottom. So now we go back and identify the strengths and weaknesses. GC is a strength, GL is a strength, GR is a strength, GV is a weakness, GS is a weakness. And coming back to the top, I said I would call GF a strength, GWM is also a strength, and GA is a weakness. And now I want to talk about the decision process a little bit. The general rule is, if an ability is within or above normal limits, it's probably a strength, which means it supports your learning or is at least adequate for learning, even if it's not optimal. If an ability is below normal limits, it's probably a weakness, which means it increases the risk of learning problems. But notice that word probably. We need to be careful about strict cutoffs, so we include this buffer zone. When scores are outside of this zone, we can be pretty confident whether an ability is a strength or a weakness. But when scores are inside the buffer zone, we need to consider everything we know about the child before making this decision. If the kid was focused and worked really hard and earned a score between 80 and 85, and the classroom evidence supports a weakness, it's probably a weakness. If the kid didn't give a great effort, or the classroom evidence doesn't support a weakness, then it might be a strength. Again, the real question is whether that ability is adequate for learning. When in doubt, you follow up. But again, that's why I usually follow up on scores in the 80s anyway. With scores between 85 and 90, it works the same way. If the total evidence doesn't support a strength, it might be a weakness. And to make the most of this process, we should start by generating hypotheses, which is a fancy way of saying we need to predict the weaknesses before we start testing. So even though all ecological data are important, whether you gather the information before, during, or even after assessment, It's better to get it beforehand so you can predict the test results because it makes your assessment stronger. Now with achievement, that's easy because the academic weaknesses are probably part of the referral question. If you get a below-average achievement score that's in that buffer zone or lower, and it's consistent with the referral concerns, it's a weakness. But the cognitive abilities aren't so clear. So for help with that, you can go back to the PSW Made Easy website and find this document. And it shows the achievement skills that have a moderate or high strength of relationship with each cognitive ability as indicated in XBAS. So normally, we use cognitive scores to predict academic performance, but we're going to do this in reverse and use the child's academic weaknesses, both in the classroom and on testing, to predict the child's cognitive weaknesses. Now in this case, the concerns are basic reading skills and reading fluency. So we start by looking at the cognitive abilities they have in common: rapid naming, and I would also include GA. XBAS doesn't indicate a relationship between GA and reading fluency, but more recent research by Linnea Airy and others has definitely challenged that. So I don't have any problems associating reading fluency with GA. So these two overlapping abilities are the ones I would predict the most. And we can also consider the abilities that are unique to each academic weakness, which are GWM and GS. So we can tentatively predict these four as weaknesses: rapid naming, GA, GWM, and GS. But we need more information than this. So another tool I've been working on is a Google form where teachers rate the students' abilities from 1 to 5. And from that form, you get a Google Sheet showing individual responses and averages. And I find that total averages below about 2 tend to predict weaknesses on testing. So in this case, even though working memory can be associated with basic reading skills, I would not predict a working memory weakness based on teacher observations. But don't expect these ratings to line up perfectly with your test scores. They won't. Even standardized measures like this don't match up all that well. And critics of CHC might use that as evidence that our tests don't measure what they say they do. But there's also a big difference between the maximal performance you're hoping to get during testing and the typical performance in the classroom, which is affected by so many other things. And if the kid has ADHD, most of this goes out the window. So it's far from perfect, but I like it because it's an easy way to get ecological data. But however you do it, be sure to gather a variety of data before you assess. And an easy way to think about it is the RIOT-I-CEL approach. RIOT refers to assessment methods, including a review of records and work samples, interviews, observations, and finally tests. I-CEL refers to assessment domains, including instruction, curriculum, environment, and of course the learner. And if you look online, you'll find several RIOT-I-CEL matrices that go into great detail. So when we make decisions, the best approach is a scientific approach. First, we make predictions, and then we compare those predictions with the test evidence. And a score below 85 is very important evidence. But you should really have more than that when it's near that threshold. So GV is kind of a tough one. I didn't predict a weakness, but I got this score of 82. And I don't have anything to contradict the weakness, but getting ecological data for GV is kind of hard, aside from my own testing observations. So with GV, I find myself relying more on the scores than I really want to. And since that 82 is all the evidence I have one way or the other, I'm going with a weakness. But on a side note, I think we give GV too much attention in this model. Is that 82 in GV adequate for learning? Well, yeah, but for the same reason that a 75 is probably adequate for learning. Because you barely need GV for learning. So I'm always afraid that GV scores add more noise than clarity. But looking at the other scores in that buffer zone, I did predict a weakness in GA. With reading concerns, that's the first thing we think about, and the score supports that. But I also predicted GS as a weakness, not only based on the fluency problems, but because we see it in class. The kid works slowly, even on familiar tasks. Assignments are always turned in late. Now the score is an 87, which is starting to look like a strength, but it's in that buffer zone, just 3 points away from being a weakness. And because I predicted a weakness, I feel more confident in calling it a weakness, right? And GF is also in that buffer zone. But in this case, there's nothing that tells me GF is a problem. It's not related to the academic weaknesses. The teachers don't observe any reasoning problems, and there's nothing in the records or from parents suggesting reasoning problems. So I didn't predict a weakness, which tells me it's a strength. So doing it this way, there's a little more legwork before testing, but you get a framework that makes your decisions more objective and defensible, and it also makes them easier. And now we scroll down the page, and I don't know why, but they put the remaining processing areas after the achievement, so we have to start from the bottom. So I put my rapid naming score under GR, although it's more like a GS-GR hybrid, and this is a weakness, which I also predicted because it's so closely related to reading fluency. Now, I haven't been using the other abilities in this section, but I do always wonder about GL and if we should separate associative memory from meaningful memory. In the other column, we have orthographic processing, and I'm just going to say what I think about this. I don't think orthographic processing is a cognitive ability. I think it's achievement. I mean, it depends on the task, but anything involving letter strings requires explicit instruction. And if you have any doubts about that, try to remember these 10 letters. Okay? And now try these 10 letters. The reason the first one was easier was because it contained familiar letter strings, and even with a couple of irregular spellings and several possible pronunciations, it still made some kind of phonological sense, because you learned about those things in school from explicit literacy instruction. But if by chance you'd received literacy instruction in Welsh, you would have remembered the second set of letters very easily, because that was a real word. Okay? So if there's a deficit in orthographic processing, I would say that's a result of a learning problem, not a cause. So I can't in good conscience use it as a cognitive weakness. I know it's controversial. That's my take on it. Okay, and cognitive efficiency is a combination of working memory and processing speed, but I don't feel a need to combine them for a PSW analysis. So now we're done with the cognitive scores, and now we enter the achievement weaknesses, which again are basic reading skills and reading fluency. Basic reading skills are an 85, and reading fluency is an 87, which seem a bit high compared to what we see in the classroom because the teachers have been very concerned about reading ever since the kids started school. But obviously we did predict these weaknesses because that's why we're doing the evaluation. And with achievement, we also need to indicate whether the score is from a composite or a subtest. And that's because they have different reliabilities, which affects how big the discrepancy needs to be. So for example, the Wyatt has a few subtests that are meant to be interpreted on their own. But again, with scores in the 80s like this, I think following up can be a good idea. All right, so those are the achievement weaknesses, and we don't need to enter the achievement strengths because they don't affect the outcome. They mean a lot to the kid, and we should think about them, but they don't mean anything in the software, so I don't waste my time entering them. And that means we're done entering scores, so we scroll back to the top and click the View Results tab. And now we come to this tab, which I don't count as one of the three because I don't have any use for it. All I do here is click See Results in PSW Analyzer. And then I get a pop-up that confirms I want to transfer the data. Then I get a reminder that I never created a record for this kid, but I like to live on the edge. And here we go. This is the exact same outcome I would have gotten if I had gone through all the test tabs, entered every subtest and every achievement score, transferred everything to the data organizer, and so on. The only difference is that when you get here the traditional way, you get a pop-up that summarizes the findings. This way, if you want the pop-up, you can look in the upper right corner and click the Display Results Again button. Does the pattern of strengths and weaknesses support SLD? No. Does this mean the child doesn't have an SLD? No. Look down here. This pattern of results does not automatically rule out the presence of SLD. You have to look at everything you know about the child. Okay? So, at the beginning of this video, I said I would talk about how to address a common criticism of PSW. And that criticism comes from several studies that showed when the model uses its own criteria and applies its own rules to diagnose SLD, the specificity is very high. So it's good at identifying kids who don't have learning disabilities. But the sensitivity is pretty low, so it's not that good at identifying all the kids who do have SLD. So in other words, if the software says the kid has a learning disability, it's usually true. If it says the kid doesn't have a learning disability, it may or may not be true. So we've been under-identifying too many kids with SLD. So, what can we do about it? This paper in 2024 by Schneider and colleagues, including Dawn Flanagan, argues that most of the diagnostic mistakes happen when the scores are right around the cutoff points. In their own data simulations, more than 90% of the errors occurred within 5 points of the cutoff scores. And the authors suggest that using buffer zones, where we apply clinical judgment, could improve accuracy. And we talked about that a little bit. But it's interesting that we have a buffer zone for determining strengths and weaknesses. And we have a buffer zone for determining average ability. But we don't have buffer zones for determining domain-specific cognitive weaknesses or unexpected underachievement, right? So looking at this tab, we can see why the PSW criteria weren't met. The scores don't show unexpected underachievement. But how do we determine unexpected underachievement? In order to have either unexpected underachievement or a domain-specific cognitive weakness on the other side of the chart, the actual score and the predicted score have to be unusually different, which is determined by this critical value, which in this case is 17.66. But the real difference between these scores, when they're not rounded, is only 14.22. So the difference score does not exceed the critical value, and that's why the XBAS tells us we don't have unexpected underachievement, right? But if we look at the numbers, we see that the difference score is only about 3 points short of the critical value. So if we have a 5-point buffer zone, it begins to look like maybe there is unexpected underachievement. And now let's take a look at the basic reading skills score and look at these two values. Would you automatically deny services to this kid because they missed this one criterion by less than half a point? That's obviously a problem, right? And the closer the difference score is to the critical value, the more likely it is that the XBAS will make the wrong recommendation due to normal score variability. Now, we can't just subtract 5 points from the critical value every time, because then we would start over-identifying kids. What we can do, and need to do, is take a closer look at all of our data when the difference score is within about 5 points of either side of that critical value. Now again, the lead author of the Buffer Zones paper was Joel Schneider, who is also one of the caretakers of CHC, and he made this helpful decision matrix to accompany the paper. And he makes a lot of nice graphics like this for his presentations, with all these flowing colors, and his CHC partner, Kevin McGrew, describes him as the Van Gogh of diagrams. And I agree. But in this case, I prefer a Mondrian. Now in reality, it should flow. I'm not advocating for hard categories. I just think it's a little more interpretable this way. So looking at the test evidence for our student, the scores are near the threshold. They're in that 5-point buffer zone. But the non-test evidence is clearly supportive. Remember I said those reading scores were higher than expected. This kid has been struggling since kindergarten, and there's also a family history of reading problems. And when it comes to reading fluency, that's hard to measure. Scores are based on speed and accuracy, but fluent doesn't mean fast. It means effortless. In this case, the score is only a little below average, but when we listen to the kid read, it's obviously effortful. It sounds kind of mechanical, with a bunch of starts and stops and self-corrections. So all that points to a fluency problem, even though the score isn't all that bad. So while the XBAS said the PSW doesn't meet criteria for SLD, the kid probably does when you look at the whole picture. On the other hand, what if the XBAS does indicate the PSW meets the SLD criteria, but the difference score just barely exceeds the critical value? And the non-test data don't sound like SLD at all, because the kid's classroom performance is really inconsistent. Their test scores are uneven, and their grades are bad, mostly because they don't turn in their assignments. So maybe it's ADHD. Maybe there's something going on at home. But it doesn't really sound like a learning disability, even if the XBAS says all the criteria were met. And if you end up in one of these white boxes, you might have more assessment to do. Maybe more testing, more interviewing. But when your assessment is finally done, if you're still in that white zone, that doesn't mean it's 50-50 about whether the child has SLD. It's more like jury duty. You assume the child is non-disabled until the evidence shows beyond a reasonable doubt that they have a disability. So if you're not in one of the green boxes, you don't have a strong argument for SLD. All right, so the lesson here is to not be rigid about interpreting your PSW data. XBAS was never intended to make your decisions for you. And these buffer zones are a helpful way to think about it, but they're really just a structured framework for how we should have been using XBAS all along. All right, so we went on a detour there at the end, but it was an important one. But that's how I make XBAS easy. Predict the weaknesses before testing based on everything you know about the child. It makes the process of identifying strengths and weaknesses easier and more defensible. Use single composites. It's the easiest and also the most reliable and valid way of measuring each ability. And finally, use these 3 tabs and a sheet of paper. Don't make this harder than it has to be. There is nothing difficult about this model. Assessment is difficult. The model is not. I hope this was helpful. Thank you.